Hi there. In this video, I'm going to show you how you can write long-running Excel functions that don't freeze Excel. So instead of functions like this, that block Excel until the function returns, using Pixel, we can write long-running functions that run in the background without blocking Excel. So with Pixel, we can write Python functions and call them from Excel just like regular worksheet functions. But one question that often comes up is what happens when those Python functions are quite slow and the user doesn't want to wait while they complete. While we can optimize our Python code and improve the speed of our functions so that they return faster, in some cases, such as reading a large amount of data from a database or calling a web service, there's really not much we can do to make them go faster. So I'm going to show you a couple of ways of improving the user experience when you have these long-running Python functions. To demonstrate this, I've written a small sample function that returns one of the standard test datasets from Plotly. I've made it artificially slow by adding a number of sleeps into the code. When we run this function in Excel, we see that while Excel is running the function, it's blocked, and Excel doesn't let us do anything else until the function returns. Each time the input to the function changes, Excel blocks, and this makes the sheet quite painful to use. The first way I'm going to show you to tackle this is using an async function. Async functions in Excel are a way to run functions concurrently. If there are multiple async functions in a sheet, Excel will start all of them and then wait for all of them to complete. And this is great when you have lots of little web or database requests or other I/O tasks that can all be fired off at the same time, but it can also be useful for long-running functions. The easiest way to write an async Excel function with Pixel is to use Python's async I/O. I'm not going to go into the details of async programming or threading in this video, so if these concepts are new to you, then I would recommend searching online for some good tutorials to understand these concepts, so you can get the most out of what I'm going to show you here. We'll take our original function and change it to be an async function. Now, async functions are really only useful when you can yield to the async I/O event loop and let other things run while you're waiting for something. And typically that's like some I/O request, like a database query or something like that. So rather than blocking using time.sleep, we need to change that to await on async I/O.sleep, which is equivalent, but yields to the async I/O event loop while we sleep. Back in Excel, if we call our new async function, we'll see the same as before. Excel blocks until the computation is complete. But now what's different is if the user attempts to click anywhere in Excel, Excel's calculation is interrupted so they can continue to use Excel. Excel shows this hash calc error, which means that the calculation was interrupted before it finished. But our function is still running in the background, and once it's completed, Excel will update with the result. Not all functions can easily be made into good async functions, and so in some cases we might need to run our code on a background thread or even using a child process. A good way to do that is to use Python's thread pool executor or process pool executor from the concurrent.futures package, which combined with the async I/O event loops run in executor method gives us a convenient way to run a function on a background thread or a child process from an async function. So this function does exactly that and runs our original long-running function on a background thread using a thread pool executor called from another async function. When we call that from Excel, it behaves just like the previous example that was using async I/O, except this time the code is running on a background thread. While using an async function is better and it allows our user to interrupt Excel, it still leaves a little to be desired. The next method I'm going to show you improves on this by adding a progress indicator so the user gets feedback and can see that the function is progressing. RTD, or real-time data functions, are typically used for streaming real-time data to Excel. A common use case is for ticking stock prices or FX rates. But we can use RTD functions for anything where a value changes over time, and that's how we can implement our long-running function with a progress indicator. The simplest way to write an RTD function using Pixel is to write a Python generator. Now, a generator in Python is a function that instead of returning just a single value, yields multiple values as it progresses. So let's take our async function from earlier and turn it into an async generator. First thing we need to do is change the return statement to a yield statement. We also need to change the function signature passed to our Excel func decorator to tell the Pixel add-in to treat this generator as an RTD function when exposing it to Excel. If we only yield the final value, then before the function is completed, we won't get any indication that the function's running. So to change that, we can add earlier yield statements, and those yielded values will appear in Excel. So let's add a hash working one at the start, and then let's add some percentage complete things as the function progresses. One final change we also need to make is to change the return type of the function again. So currently we've set it to RTD data frame, which tells Pixel it's an RTD function that returns a data frame, and that's how Pixel is able to apply the correct conversion from the data frame to an Excel array. But now we're also yielding strings, so we have to change the return type to a union. So this union lets Pixel know that the return value can either be a data frame or a string, and it will pick the right conversion accordingly. Now, when we call our RTD long-running function in Excel, immediately we get some indication that the function's running, and when it's complete, we see the final result gets updated in Excel. So Excel is no longer blocked while our function's running, and the user gets feedback so they know that everything's working correctly. There's just one final consideration I want to look at, and in Excel usually RTD functions are used for streaming data, and when Excel recalculates they don't restart from the beginning. We can see that in our last example. If I wait for the function to complete and then force Excel to recalculate by pressing Ctrl-Alt-F9, our function doesn't start again as we might expect, but we see that the last result is yielded back to Excel. Now sometimes this might be exactly what you want, for example if you're loading a large data set and you never want to reload it, but other times you do want the user to be able to recalculate and have your RTD function or generator be restarted. So Pixel has a feature that enables exactly that, and it's called auto-detaching. Auto-detaching detaches the Excel RTD function once that final value has been yielded. That turns the function into just a normal function again from Excel's point of view. So once the RTD function has been detached, recalculating calls your Python generator again and the RTD function starts over. To turn this on, we add the auto-detach type parameter to our RTD type. And once that's done, we can see that in Excel, pressing Ctrl-Alt-F9 after the function is complete causes it to start again. Over this video, we've looked at a couple of approaches for dealing with long-running functions. We saw how to take a long-running function and turn it into an async function that can be interrupted by the user, and then we wrote an RTD function that can give progress feedback to the user while Excel's calculating, but without blocking Excel. And we also looked at Pixel's auto-detach feature, which makes using RTD functions much more suitable for this long-running function problem. So I hope that's all been helpful, and I hope it gives you some ideas of how you can make your worksheets more responsive when dealing with functions that take a long time to complete. I'll share all of the code used in this video in a link below, and if you have any questions, please get in touch via the contact form on the Pixel website.